Okay, welcome back. Let's revisit our little list here of what we're covering to see where we're up to. Okay, so we've done 0, an end-to-end Scikit-learn workflow, and we've done 1, getting your data ready. So now we're going to do number 2, choose the right estimator/algorithm for our problems. Let's make a little heading for that. 2, choosing the right estimator/algorithm for our problem. Now, a little thing to note here is that Scikit-learn, let's just put it here, Scikit-learn uses estimator as another term for machine learning model or algorithm. So that's an important thing to note, like you'll come across if you're using the Scikit-learn documentation or if you're just browsing general machine learning stuff online, you'll hear a few different names for it. So machine learning model, machine learning algorithm, or estimator in the case of Scikit-learn. They kind of had their own nomenclature to just make things a bit more easier across the library. But if you hear those kind of terms, just remember, it's talking about using a machine learning model. Okay, now how do we go about this? Well, some other things to note is that, first of all, before you choose an estimator/algorithm for your problem, is you have to figure out what kind of problem are you working with. And up here, we've seen a few different types of problems, but the main ones we're going to be looking at are classification, aka predicting whether a sample is one thing or another, and regression, predicting a number. So classification is like our heart disease problem, right? We're trying to predict whether someone has heart disease or not. And regression is we're trying to predict a number, like with the Boston housing dataset or with our car sales dataset. We're trying to predict a house price or a car price. That doesn't look very good. Let's go dot point this. Things got to look good, right? So in the previous examples, I've kind of just randomly imported this random forest regressor, but where did I get that from? And I'll let you know on a little secret, it's not that trivial. There are a lot of different machine learning models, but Scikit-learn has made something very helpful, and I'm very excited to show it to you. Let's have a look. So let's go Google Scikit-learn ML map. Choosing the right estimator. This is what we want. This, when you first see this, it's going to look like a whole bunch of just different jargon going through. But as we start to dive into it, we'll start to realize, oh wow, this has some really useful things that we can use in our problems, our machine learning problems. And what is this? Well, it's at this website here. You can just go Scikit-learn or Scikit-learn machine learning map in Google. And this is choosing the right estimator. Remember, estimator in Scikit-learn is the same as machine learning model or machine learning algorithm. And the documentation here says, often the hardest part of solving a machine learning problem can be finding the right estimator for the job. Yes, different estimators are better suited for different types of data and different problems. Ah, that makes sense. So if we have a classification problem, we might want to use one of these estimators. And if we have a regression problem, we might want to use one of these estimators. And then for something like a clustering problem, we have these estimators. And then for something like a dimensionality reduction problem, we might want to use one of these. But let's get hands-on, right? Because at the moment, this graph or this flowchart, this map, whatever you want to call it, it can seem a bit confusing to begin with. So what we're going to do is get hands-on with a problem. So if we start here, first we need some data. So this is what these little blue steps ask you. Do you have above 50 samples? No. Get more data. Simple. Do we have above 50 samples? Yes. Predicting a category? Yes. Do we have labeled data? Yes. Do we have under 100k samples? Yes. Use linear SVC. Ah, okay. All right, enough talk. Let's get back to our notebook and start writing some code. What we're going to do is, to begin with, 2.1, we'll see how we did regression just recently, so we'll see how we would pick an estimator/algorithm for a regression problem. So let's do this. We'll make 2.1 picking a machine learning model for a regression problem. Beautiful. And so what we're going to do is we're going to use one of Scikit-learn's built-in data sets, and that's the Boston housing data set. So let's go import Boston housing dataset. And we can do that from Scikit-learn.datasets, import load Boston. And then we want to go Boston, just to set it up, equals load Boston. And then we want to see what it looks like. Boston. Okay, so it imports as a dictionary. We've got data as one of the keys, target as one of the keys, and then I think we have here feature names. What can we do with this? Well, let's first turn it into a pandas data frame so that we can see it a little bit better than being in a dictionary. So we'll go Boston df. Now, this is one of the first steps you'll usually do with any kind of problem, with any kind of data set, is try to get it into a pandas data frame, right? Because we've seen what pandas is capable of, and we know it looks good, and we know it's pretty malleable, and we can just do a whole bunch of different things once it's in a pandas data frame. So rather than having it in a dictionary, we'll get it into a data frame. And then we want to set up Boston df, and I'm kind of typing here without talking, but essentially what I'm doing is I'm taking the data key from the Boston dictionary and setting the columns to be the feature names from the dictionary, and then creating a target column here. This is what we'll be trying to predict by setting it to PD series and then taking the target key from the Boston dictionary. So right now, Boston is a dictionary, and we're going to turn it into Boston df, which is a data frame. So let's see what this bad boy looks like. Key error. Features names. Oh, it might just be feature names. Columns, lots of typos. This is what happens when you type and talk. Okay, excellent. So what can we see here? Well, we've got crim, zn, indus, chas. Not sure what all of these are, but it's got a target column. So I'm assuming that's what we're trying to predict, and we can figure out what this actually is by just going Scikit-learn Boston housing dataset. We look here, datasets.load Boston. So this is what we've just done. We've called this function from the Scikit-learn.datasets module. We can read more in the user guide. I've seen this before, that's why I'm kind of familiar with it, but if you're first looking at it, you might have to dive in. So this is just going to give us a data dictionary of what the columns that we're dealing with. So if we see crim is per capita crime rate per town. Yep. Okay. And then zone, proportion of residential land zone for lots over 25,000 square feet. Yep. Okay. So long story short, what this data set is a whole bunch of different parameters about different towns in Boston. So each row of these, Boston is a city in America, by the way. So each row is a different town in Boston, and there's different features about this town. You can read all of these here. And what we're trying to do is use these features about the town to predict the median house price. And I believe this house price is in thousands, and this data set's a little bit old, so that's why everything's so cheap. But the premise is here. This is a regression problem. So now we can figure out a few things about our data frame. So we want how many samples. We're going to go len Boston df. 506. Wonderful. So now that we know we have 506 samples and we have a regression problem and we have labels, what can we do? We go back to our machine learning map. We come right to the start and we go, okay, we go follow this little golden arrow. Beautiful. Do we have above 50 samples? Yes. See, if we didn't have above 50 samples, Scikit-learn would be telling us get more data, which makes sense. Are we predicting a category? No. Are we predicting a quantity? Yes, because we are working on a regression problem. Do we have over 100k samples? Under 100k samples? Yes. Few features should be important. We're actually not sure what this is. So few features should be important. What can we... We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We've got 13 features, but we don't actually know whether a few of them will be important or not. So let's just pretend no for the time being. And so this is going to point us now to one of these green squares. And within each of these green squares is an estimator or a machine learning model. So if we click on this one, ridge regression, this is going to take us to the ridge regression and classification documentation. So it tells us ridge regression. Ridge regression addresses some of the problems of ordinary least squares. Then we got a whole bunch of math symbols, but really we just want to work out how we can use this machine learning model. Okay, so from Scikit-learn import linear model, Reg. Okay, so we can just import it like that. Well, let's see. Let's go back. Let's get some code working. Let's try the ridge regression model. So if we go back up here, if we go from Scikit-learn import linear model, and it's linear model.ridge to use the ridge regression. But actually, we don't want to just do it like that. Let's skip a line of code, and we can do it by going from Scikit-learn dot linear model import ridge, and then we're going to set up a random seed, mp.random, so we can make sure our results are reproducible. And then we want to create the data. So we're going to go x equals, we've seen this before, Boston df.drop. We want to drop the target column for x because that'll just be the features matrix. Axis equals 1. I'm going to put a few rows down here so we've got some space to see. Y equals Boston df, and this is going to be the target column because we want to use x to predict y, right? And then we want to go split into train and test sets. We're going to go x train, x test, y train, y test equals train test split x, y, test size. We use 20% again because that's a good general number. You'll see that come up over and over again in machine learning projects. And then the next thing to do is, because we've imported ridge, much like up here, we've instantiated the model with random forest. So model equals random forest regressor. We can do the same thing with ridge. So we go instantiate ridge model, and we'll call it the generic model again, ridge. And then we're going to go model.fit, x train, y train, and then we want to go check the score of the ridge model on test data. Model.score, x test, y test. Beautiful. Look at that. How quick was that? So what did we do here? Where did this come from? Remember, we went back to our machine learning map. We started here, we answered a few questions and followed the flowchart along to here, and then we clicked on ridge regression. And that took us to the documentation. And we went here, okay, there's some example code, but we prefer to just start typing it out ourselves, which is what we did here. Kind of skipped over looking at this because I wanted to just get it in here so you can get an example. And so now what we've done is we've split our data into x and y. We've got our Boston data frame here. We've taken these columns because we want to use these columns to predict the target. And so that's what we've done, x and y. Then we split into train and test. And we've instantiated a ridge model because that's the model that the map suggested we should use. This bad boy here. And then we fitted it to the data, aka asked our model to find the patterns between x train and y train. And then we evaluated our model on the test data set. Wow, that was actually surprisingly easy. Now, this score, what is this? So this is, if we press Shift Tab, returns the coefficient of determination, R squared, of the prediction. Now we'll look into more evaluation metrics as we go on, but just remember the highest possible score you can get here is 1.0. So if our model was to predict each of these columns exactly, then it would get a score of 1.0. So 0.66 is not too bad, right? The closer to 1, the better. What you might be asking is, how do we improve this score? Right? What if ridge wasn't working? And luckily, if we go back to the machine learning map, we've got a little arrow here that says not working, right? So if our ridge regression wasn't performing as well as we wanted, or wasn't working at all, well, this arrow's pointing us here to go to one of these two green rectangles. So maybe we'll have a look at this in the next video. What's going on here? What if ridge regression wasn't working? At the moment it is, but we want to kind of improve this score. So we'll check out what we can do with that in the next video.